So I've managed to pick up a tube checker to add to my collection of junk over the past little bit. Come across a lot of tubes and wanted a way to kind of quickly go through them to see which ones are still good and which ones just need to hit the junk bin. Overall, this tube tester's in pretty good shape. It's a bit grungy. The top cap cable is cracking pretty bad, so I'm going to replace that. It's dirty. Knobs are kind of loose. They're not connected to the filament voltage switch anymore. Plate voltage I haven't checked to see if it's working. Set line does work, and then the type switch seems fine. The scroll of different tubes here are all, it's working pretty good. The plastic is kind of pushed down, so it needs to be fixed up a bit, and that as a quick test, it does power up, and you can see that the meter's swinging away there. Set line to trim the input voltage so that it's testing at the correct levels all seems to be working decently. Hard to say where my line voltage is at exactly in relation to this thing, so set line's turned quite low to center it, but yeah, it seems to be working okay. I can't, I don't have anything hooked up, so I can't see if the neon tube for the short test is working, but that'll be a quick little test to do once I get a little bit further along with testing it. So I wanted to give a quick look at the back side of this device. I wasn't sure what I was getting myself into for components and that. I've been through a lot of other tube equipment, and often there's a ton of capacitors and components that just need to be checked out. Overall, this thing's pretty simple component-wise. Transformer, both filament and high voltage. Banks of switches here to switch signals over to the various locations on the tube. Type selector and that. The only component that I've found that is of concern is this type 33 capacitor here. I'm pretty sure that it is a paper foil capacitor, so it is probably very leaky at this point. So I am going to pull it out and just do my due diligence and replace it and get it replaced with something modern. The other component that is of concern maybe is this rectifier here. I did do a little bit of homework, and it should not be selenium based rectifier. It should be a copper oxide, but it's worth double checking to make sure that it's working correctly and see whether it needs to be replaced. Because this is a kit, I do want to go through the wiring with the schematic and just double check that it was built correctly out of the box. You don't want to live with someone else's mistake from when it was built incorrectly in that. But that should be just a simple case of going through with the meter and probing everything out and make sure that it's all okay. Underneath the transformer here is the filament voltage switch, so that's what lets you get everywhere from just a handful of volts up to I think about 100 volts filament voltage. All the switches look to be in good shape. They're oxidized. This kit's from the late 50s more than likely, so I'll give them a quick cleanup with some contact cleaner and contact lube just to make sure that everything's moving nicely. The paper scroll is in really, really good shape. It's not, dried out or cracking or anything like that. I do notice that it is rubbing on this metal plate here for the lamps. So I'll be, pulling things apart, just getting it straightened out and just making sure that everything is in good shape from that perspective. The resistors in that should all be fine, but really it's a trivial exercise to go through and check them in circuit and just make sure everything is in good shape. So yeah, we'll give it a once over, make sure everything is working okay, and then give it a shot with some tubes. So you can see here that I found a copy of the TC-2 tube checker manual from Heathkit. It's about a 1955 copy, I believe. So this will be really helpful in trying to figure out and get this tube checker up and running again. Scrolling through, you can see a couple different variants of it. The one that I have here, that's just in a wooden box, and they sold a fancier version that you could get in a carrying case. Here's the schematic for the tube checker, and it is pretty straightforward. Let me get it rotated here. So this is the primary side of the transformer. This is the set line potentiometer here that you use to set the appropriate voltage up on the output side. Here's the filament voltage selector, so you can select from 0.75 up to 110 volts through this switch here. Plate voltage potentiometer, the neon short indicator here that I still have to check out to make sure is working okay. This is the type selection switch here, and this is the test switch here. Pilot lamps, and then here is the bank of switches for putting the appropriate voltages on the different pins of the tube. So a couple of the components that I pointed out that may be of concern, the 0.1 microfarad capacitor here, up here, like I said, in my quick little bit of research, it's a type 33 capacitor, which I believe is a paper foil. I haven't really wrenched on it yet, but I believe it is a 0.1 microfarad, and that's shown in the schematic here, 600 volt. I'm not sure why they put a 600 volt cap in, as this thing does not output quite that voltage, but that's what it was populated with. That's what I will replace it with. Here is the diode that I was pointing out earlier. It should be straightforward to check if it's working correctly, and I believe it is based on the behavior of the unit. This diode only really appears to get used in the non-test mode, so in the setup mode when the meter swung into its center position. So you turn the set line voltage pin here, this rectifies it, and it goes through here into the meter. So that was setting the meter up into its centered location. You can see here, this is the actual test switch. So when you flip this switch, this contact moves from 1 to 2, this contact moves to 5 to 6, and it bypasses this diode here and then puts your tube in circuit. So it really should be easy to find a replacement diode for that if there is a concern, but like I said, because the meter is centering properly and set line functionality appears to be working, then this diode is more than likely just fine. Up here are the type switch to flip between the different tube types. Down here is the bank of switches that you switch up and down to connect different elements of the tube from basically power and ground. Now, this is not a emissions tester, it's just a tube checker, so it really doesn't check to see whether an appropriate amount of current is flowing through the tube. The check is to basically make sure that the filament is warming up, that it is then capable of rectifying a current like this diode is, and also able to check to make sure that the grid and plates are all disconnected appropriately from each other, that they aren't shorted together. So part of the test is moving these switches into various positions and flipping the test switch and double checking that the neon short indicator is not turning on. So really pretty straightforward test for the tubes. Like I said, not specifically an emissions test, but it will tell you whether your tube is functional and whether it looks like it appears to be good. So I have the tester taken apart now and have the capacitor disconnected from the circuit. Looking at the schematic, more than likely I could have just tested it in circuit, but better safe than sorry. I just want to make sure that there aren't any other paths that things can take. So disconnect one end of the capacitor, and I have it set up right now for leakage testing. You can see that I have it charged up to 61 volts there. DC supply showing the same thing, and I'm seeing about 1 microamp of leakage through that capacitor, so it's actually not that bad. You know, obviously it's nowhere near the 600 volts that it's rated for right now, but 60 volts is as much as I can go. So I'm just going to turn my current limit down. You can see that the voltage is coming back down on that cap, and current's measuring back the other way. So we're just going to let it discharge here. Down right close to 0 volts. and I'm just going to turn my current limit back up, and you can watch the voltage climb again. Some current limits up, and actually I turned up the current limit a little too quick and it shot right up to voltage again. But again, you know, around about 1 microamp of leakage. So I don't think that that's too bad for this type of cap, and for what this thing is doing, I'm really not freaked out about a little bit of leakage through that capacitor. Really should not be a big deal for the circuit. So I think I'm actually just gonna reconnect it and call it good for now. Maybe a little bit more homework before I finalize on that, but I don't think that that capacitor is as leaky as what I thought it might be. So I do have the capacitor connected back up on circuit now, just connected into that tab. I haven't soldered it yet. I'll do that shortly, but I just wanted to see if I got a different result with it in circuit. So you can see I've 40 millivolts across it right now. I'm just going to turn up my current limit and start charging that cap up again. Okay, so there it goes, charging up. 40 volts, 50 volts, and 60 volts. So that's charged up. You can actually see the current limit, or current being measured now. The leakage current is actually a little bit higher. It's 1.3 microamps instead of you know, just around 1.0, 1.1 microamps. So I don't know, it could be just that I disconnected you know, the alligator clip, so I'm getting a slightly different reading. But really, again, I don't think a microamp of leakage on that capacitor is really going to be a big deal at all. So I'm just going to leave it. I like to keep things original if I can. So we'll keep it in place. It measured the right capacitance and has relatively low leakage, so we'll call it that. So I have the TC-2 tube tester back together after testing that cap for leakage. Like I said, I was happy with the results of it, and I know being a paper wax foil cap that, you know, it's not going to last forever, but it seems to be fine. So I'm just going to leave it in. So it's all back together. I have, you know, sanded it, gave it a nice coat of Varathane in that just to clean it up a little bit. But you can see that you know, it's up and running, and you know, overall the operation seems to be good. Set line is working okay. And then what I'm going to do is just hook up my voltmeter here. Just give me 1 sec. I'll just give kind of a quick theory of operation here. So the bank of switches along the bottom basically switch each of the pins of the tube between ground, plate voltage, and filament voltage. So if I just grab my probe here, I have one of them connected to the top connector just for the ground. So the center position on these switches is ground. K is connected to that top plate connector, so it's grounded at the moment. I'm just going to go in up over here and you know, plug into pin 1, which lines up to switch A. So just to show you here, sorry, I'm gonna get my meter set up properly again. Go to AC voltage. So right now you're seeing basically no voltage there. Now if I flip this down to that position, you'll now see that I have 6.4 volts. Over here I'm set to 6.2, so that's the filament voltage. And just to kind of show you, we can go up to 100 volts. Two volts. So that indeed there is the filament voltage. And we're just going to set back to 6.2 now just to be safe, because most of my tubes are there. And then the other position for the switch here is plate voltage. So that should take us up to round about 90 volts. You can see set line here takes us up over, you know, 110 volts down to 80 some volts. So basically the theory of operation is that it warms the tube up, applies voltage to the plate, and then checks to see that there's a current running that the meter then shows. There is a short detect on the device as well, so it will check to see if the plate voltages are shorted either to filament pins or ground pins. And earlier I actually did end up blowing up my 500 milliamp fuse with this test earlier on, but that's okay. So you could still have that top connector connected to ground. So I'll connect in here to pin 1, and you'll see that as soon as I flip that switch up, that short light here comes on. So that's basically telling me that that the plate voltage is shorted to a pin that it shouldn't be. You'll notice that filament voltage isn't affected there. No, sorry, I just lost my clip. And actually, I silly me just shorted filament voltage to ground there, but that's okay. Meter still should be okay. I didn't take out my fuse, but you can see there that's plate voltage shorted to ground, plate voltage shorted to filament voltage. So that light, if it ever comes on with the tube, means that you have a short in the tube that you shouldn't have. So it's going to take my meter away here. I think I kind of showed everything I wanted to there. And we're going to throw a tube into it. So I have a good old Russian tube here, 6H8C, which is equivalent to a 6SN7 tube. So this is the chart here. So it took me a bit to get it operating well enough again, but it's easy to get the paper too tight and it doesn't want to move freely when you're out at the extremes of the paper, but yeah, it's adjusted quite nice now. So we'll go to the 6SN7, and this table here basically tells you how to go about testing your tube. So we need to go to type 2, filament voltage 6.3, and then the plate should be set to 26 here, and we will throw our tube into the socket like so. And then here's the switch settings. So top, I need to be switching D and E to the top, and then F and G need to switch to the bottom. So as soon as I flip G, which is marked in bold, you should see the tube starting to warm up. So that's grounded one side of the film, or this is applying filament voltage to G. H actually happens to be the ground for filament voltage. I can show that later on. And then D and E are set up for plate voltage here. So you actually want to also make sure that your set line is well centered, like that. And then basically pull the lever down to test. So that went up into the green. You'll note that there's nothing showing shorted at the moment. And the instructions do tell you that you want to move all the ones that aren't in bold between all the positions, just to make sure that that short lamp doesn't come on. Okay, so nothing there. Again, test shows that it is in the good region. And while you're testing, you actually move the switches that are on the plate voltage back down to ground, just to see, yep, we have a dip there. We have a smaller dip there. So D is going to be probably the plate. This is a grid. And then this will be one. Yeah, I'm not sure exactly which one that'll be. I have to look at the tube. So that's test number 1 for the tube. Test number 2, very similar. G goes down, C goes down, A and B go up. Quick test through. Nothing with the short light, so we're going to pull that down, and it is testing as good. And again, a dip and a smaller dip. So that tube, according to this tester, has tested as good. So yeah, it's not the best tester in the world. It's certainly not going to do tube matching for you. It's not going to tell you necessarily how good the tube still is. It's going to just basically tell you that the tube is functional. For my needs right now, that's kind of what I'm looking for. Just trying to repair some old radios and that kind of stuff. Not doing hi-fi equipment and that at all. But yeah, so that's the TC-2 tube tester.